gravity, it's usually the sound of the circular saw. Its spinning teeth can take a bite out of any job in seconds. There are many claims to the invention of the circular saw, but there's no doubt that when its design was perfected in the last century, it revolutionized woodworking. With a circular saw, you can give odd jobs a whirl, and when the sawdust settles, you may have discovered your inner handyman. To make a circular saw blade, a laser burns into a sheet of steel to cut out jagged discs in the basic shape of a circular saw blade. They feed each disc to rollers that press grooves onto both sides. These grooves are tensioning rings that will keep the blade from vibrating while cutting. Without these grooves, the circular blade wouldn't cut straight. At the next station, the assembler measures sags and buckles before feeding the discs to a machine that rolls them flat like a pie crust. A grinding wheel polishes the blade. And then they load barrels of the discs into an oven to bake until they're very hard. This will take about 24 hours. Meanwhile, carbide tips for the blade's teeth funnel past a laser that confirms they're properly positioned for the next step. A robot then picks up one tip at a time and delivers it to nozzles. The nozzles pump a paste called flux onto it. Another robot places a piece of solder metal on the flux. The next robot delivers the tips to the saw blade body. Elements melt the solder metal and flux to fuse the carbide tips to the teeth. It's a technique called brazing. Teeth with carbide tips last longer without losing their sharpness. Circular blades for sawmills have a larger and different design. They brush flux around a side hole and then place soldering metal on an elongated carbide tooth. They braze the tooth to the flux-coated hole and install several more of these carbide side teeth. The side teeth will enable this sawmill blade to tear through big logs. The smaller circular saw blade now spins on an axle while a spray nozzle sandblasts it. The sandblasting cleans the surface and gives the blade a brushed texture. A mechanical finger now moves one of the blade's teeth into position for sharpening. A grinding wheel tapers each tooth. A different wheel moves in and grinds the outside diameter of the blade. The geometric angle of the grinding can vary depending on the type of blade being made. The grinding wheel then hones the face of each tooth to give it a sharper edge. Next, a straightening specialist pounds out any remaining bumps in the blade and double-checks it with a straight-edge tool. He wipes off any smudges and then holds the blade to the light and examines it to confirm that it has no flaws. A laser then etches the company insignia onto the blade. And now this circular saw blade is ready for its close-up. A camera focuses on the teeth and sends the picture to a computer. It analyzes the cutting angle and the clearance of each tooth to make sure each one measures up. The result is circular saw blades that should be able to keep their edge on the job.